In this video, let's look at parts A and part B, part A and part B. A says, here's this graph, right? So they drop it on the moon. Here's this displacement. It's showing it, this object's falling, right? It's moving down. Okay, so state the significance of the negative values of S, right? And what they're trying to get at is that down is negative, right? Okay, so see if you can explain that to them. It's only one mark, but there it is, right? And then it says, B says, use the graph to estimate the velocity of the ball at 0.8 seconds. Now, one way to do this is to figure out 0.8, right? Remember, every two of these is, so there's 0.8, right, is about there. So draw a dot there, and then I really can't do this with this, but you're going to draw yourself a tangent line. Something like that. But use a straight edge, right? Read these points, and then use the slope is what, y2 minus y1 over x2 minus x1. Okay, I did it all the way across there, so our run will be about, what, 2.25 seconds or something like that. Read it carefully, right? So be careful. In this direction, every square is 1/100th of a meter. In this direction, every 2 squares is 1/10 of a second or something like that. So just read it carefully. So this is way number 1. Okay, that's your slope, and therefore it's your instantaneous velocity, right? Method number 2, though, is it just said use the graph. It didn't say use a tangent line, right? So the other thing you can do is you can look at, say, this point right there, right? Notice that we are, what, 3.2 down, right? Right, so S is minus 3.2. The time is, what, 2 seconds? It's released near the surface at time 0. Evidently, I'm guessing it's released from 0, right? It looks like it's tangent at 0. Can't you solve for the acceleration from this, right? Use no v, and then do suvat again, right? It's like a 2-step problem, right? Use that acceleration you just got. Okay, and the initial velocity is 0, and the time now use 0.8 seconds. Solve for the final velocity, right? Wouldn't that be the velocity of the ball at 0.8 seconds? So 2 ways to do it. You could do both ways if you're talented and gifted. I'm just talented, so I'm just going to show you one way. Wait, I showed you 2. Okay, so now let's look at the second part, right? Calculate the value for the acceleration of free fall close to the surface of the moon. Well, now there's 2 ways to do that, right? You can either go v is u plus at, and we know, I think you figured out the velocity at, say, 0.8 seconds. You found the final velocity. That's your answer to letter I, right? To B, letter I is that one, right? And the initial velocity is 0, so you could figure out the acceleration from that, right? Another way to do it is, of course, to just do the suvat, right, that we did in the previous part, that at the very end of that curve, you're down 3.2, the initial velocity is 0, time is 2 seconds, suvat for the acceleration. 2 different ways. They arrive at very close to the same answer, so remember they're estimates, so they're not going to be exactly the same. All right.